Hello guys, this is geometry lesson 6-6. In this lesson, we'll learn how to identify rhombuses, rectangles, and squares by the characteristics of their diagonals. So it's about conditions of special parallelograms. It's the last lesson of the topic. So we're going to combine everything that we learned and try to identify what's the difference between rhombuses, rectangles, and squares just by looking at their conditions. Let's first look at model and discuss. The sides of the lantern are identical quadrilaterals. Okay, so they're all same. Identical means congruent, quadrilaterals. Part A, how could you check to see whether a side is a parallelogram? Justify your answer. Okay, so a side of the lantern is this whole thing, this whole quadrilateral. So how could you check if this is a parallelogram? You could measure the sides and see if they're congruent. What else? You could measure the angles and see if the diagonals bisect the angles or if there are any relationships between the interior angles and see if it makes parallel lines for the opposite sides of the parallelogram. So let's write here, part A. You can say you can measure the sides. And what happens to the sides? Like, what are you looking for? If they're congruent, if opposite sides are congruent, then the lantern window is a parallelogram. If all the opposite sides are congruent, the lantern window is a parallelogram. You could also measure diagonals. Measure the diagonal and the angle. Let's just do measure the diagonals, yeah, and the angles. If the diagonals are congruent, it is a rectangle, right? What else do you know? The diagonals are perpendicular. What are they? It is a rhombus. It's obviously not a rhombus. Okay. So this is part A. Okay, part B, does the side appear to be rectangular? How could you check? Just by looking at it, do you see a shape? Like, how could you identify this quadrilateral? It's more like a rectangle, right? It has right angles on the sides, on the vertices. And you see two parallel lines, right? Two pairs of parallel lines. How do you check? Let's put B over here. Okay. Appear to be rectangular. Yes. You can measure the angles at the corners. If they are right angles, then it is a rectangle. Okay. So this is B. And part C, do you think that diagonals of a quadrilateral can be used to determine whether the quadrilateral is a rectangle? Could you determine using the diagonals? We just learned that in the last lesson. What do you know? The diagonals, if the diagonals make a right triangle, right? So like they make right triangles here and here. And you can prove the triangles are congruent, and then you can say the parallelogram that have right angles. And you can say it's a rectangle. Or you can use the Pythagorean theorem to verify right triangles. And then you can show that the lantern sides are rectangles, right? And we also learned that if the diagonals are congruent, then it's a rectangle, right? So let's summarize that. Yes, the diagonals make right triangles by using the Pythagorean theorem to verify right triangles. You can show, or we can show, the lantern sides are rectangles. Because the diagonals okay. So use what you know about the properties of the shapes. Okay, so this lesson will learn the diagonals, the properties of diagonals of a parallelogram to classify parallelograms. So example 1, we're going to use diagonals to identify rhombuses. Information about diagonals can help to classify a parallelogram. In parallelogram A, B, C, D, AC is perpendicular to BD. So in other words, the diagonals are perpendicular. What else can you conclude about the parallelogram? If they're perpendicular and the opposite sides are parallel, what can you say? Well, another information that you know about any parallelogram, the diagonals of parallelogram must bisect each other. So the diagonals are perpendicular bisectors, which means BE is equal to DE, AE is equal to CE. Any angle at E either forms a linear pair or is a vertical angle with AEB. So all 4 angles are right angles, right? So we have 4 right triangles created, and they're congruent by SAS theorem, because you always have this side that's congruent to that side, and the shorter side is congruent to the shorter side. So all the triangles are congruent by SAS. And by CPCTC, you can say that all sides are congruent because they're corresponding sides. All the hypotenuse are congruent, right? So then you can say it's a rhombus. You can't say the angles are right triangles here at the vertices. So you don't know if it's a rectangle. It's actually not a rectangle. So all you can say here is that the parallelogram has 4 congruent sides, so it's a rhombus. All right, look at try number 1. If angle JHK and JGK, so JHK is here, and JGK are complementary. Complementary is what kind of angles? You know the supplementary angles make 180 degrees. Complementary angles make 90 degrees. So in other words, JHK plus some measure of JHK and measure of JGK is equal to 90 degrees. What else can you conclude about GHJK? Can you identify this parallelogram? See if you can justify your answers and explain. Come back when you're ready for answers. So if they're complementary, what do you know? By alternate interior angles theorem, HJG must be equal to KGJ, right? So these two are not equal. So maybe I should say, oh, this is two lines here, okay? But here and here, they're equal. They must be equal. Maybe I should use a different color. Okay, so these two are equal to each other by alternate interior angles theorem. So JHK and HJG are also complementary. Yeah, so these two are also complementary. And using the triangle angle sum theorem, you can figure out that HLJ must be a right angle because if they're complementary, they're 90 degrees. And a triangle has a total sum of 180 for the interior angles. So this last angle must be 90 degrees. Right? So the diagonals are perpendicular because all right triangles here are congruent by the SAS theorem. Yeah. So it's a right angle, so diagonals are perpendicular. So if they're perpendicular, you know it's a rhombus. So let's summarize that and write it down. So we can start by saying GHJK is a rhombus, and you're going to prove by the alternate interior angles theorem. Angles HJG and KGJ. So angles JHK and HJG are complementary. And using the triangle angle theorem, angle HLJ is a right angle. So the diagonals are perpendicular. And when the diagonals are perpendicular, the parallelogram or the quadrilateral, or we can say parallelogram since it's given that opposite sides of parallelogram. Parallelogram is a rhombus by the converse of theorem 6-16. So in the last lesson, we had a theorem that says if a parallelogram is a rhombus, then its diagonals are perpendicular bisectors of each other, right? So the converse would be the other way. If the diagonals are perpendicular bisectors, then parallelogram is a rhombus. Okay. So theorem 6-19 is actually the converse. They're exactly the same thing. Converse theorem 6-16, basically, if the diagonals of parallelogram are perpendicular, then the parallelogram is a rhombus. And converse of theorem 6-17 says if a diagonal of a parallelogram bisects two angles of a parallelogram, then the parallelogram is a rhombus. Okay. So we learned the characteristics, these characteristics in the last lesson, but we're gonna use the converses to determine what type in this lesson, okay? So example 2, we're gonna prove theorem 6-20, which is the converse of 6-17. How can we know if the diagonals bisects two angles, then it must be a rhombus. It must always be a rhombus, right? So it's given parallelogram FGHJ with 1 congruent to 2, angle 3 congruent to 4. Basically, this one diagonal bisects the end angles, right? So first, by ASA, we can say that the triangles FHJ and FHG are congruent, okay, because FH by reflexive property is congruent to itself. So angle, side, angle over here, angle, side, angle. So CPCTC, FJ is congruent to FG because they are the corresponding sides, okay? So you need to know, after proving the triangles are congruent, make sure you know which sides are corresponding to each other. Is FJ corresponding to GH or FG? Okay. These two are corresponding. So by the alternate interior angle theorem, you can say that 1 is congruent to 4 because they're parallel, right? So 1 is also congruent to 2 and 3, and for all angles are congruent. And by the converse of isosceles triangles theorem, FG must be congruent to HG, right? If all the angles, if the base angles are congruent, then it's an isosceles triangle. So the other sides here, the legs of the isosceles triangles must be congruent. So using the transitive property of congruence, all sides are congruent. And since FGHJ is a parallelogram with congruent sides, it's a rhombus. All right, now we prove it. So if we're given any diagonal that bisects the angles at the vertices, then we know it's a rhombus. This is how you can prove it step by step, but thankfully you don't have to prove it every time you use this property since we have the theorem 6-20. You can just say by theorem 6-20, it's a rhombus, okay? So try number 2, you're gonna refer to figure FGHJ in example 2, use properties of parallelogram to show that if the angles 1, 2 are congruent and 3 and 4 are congruent, then 4 angles are congruent. I think we already proved that they're congruent by the alternate interior angles theorem, but they want you to use properties of parallelograms. Okay, so instead of using the alternate interior angles theorem, how could you prove it using properties, just using the properties of parallelograms? So what were the properties of parallelograms? Think about it. What are the things that we learned last lesson? See if you can apply any of them. Okay. So what do you know about parallelograms? Opposite sides in a parallelogram must be congruent. So you know that GFJ must be congruent to GHJ because opposite angles must be congruent, right? And so let me draw that. Sorry, it's not drawn to scale. I'm trying to explain it. So you know that opposite angles are congruent in a parallelogram. So F and H must be congruent. And then since 1 plus 2 is GFH and they're congruent, these angles are congruent to each other, it must be, this diagonal must bisect the two angles, right? And 2 times angle 3 is this angle. And 2 times angle 1 is also this angle. And since the angles are the same, right? So 2 times GHJ, 2 times angle G, let's do, no, 2 times angle 3 is equal to angle GHJ, right? GHJ. Wait, GHJ. And then 2 times angle 1 is equal to angle GFJ. And so since the angles are congruent, we can say that by substitution, you can say 2 times angle 3 must be equal to 2 times angle 1, or congruent, which is basically equal to for the measures. And so you can also substitute other angles. Then 2 must be equal to 3 because 1 is equal to 3. And 1 should be equal to 4 because 2 is equal to 4. And so all the angles are congruent. Okay, so now we've proven all 4 angles are congruent. So let's summarize that in words and write that down. You can say opposite angles in a parallelogram are congruent. So angles GFJ and GHJ are. And since angles 1 plus 2 is equal to angle GFJ, angles 1 and 2 are congruent. You can say that 2 times angle 1 is equal to angle GFJ. Similarly, you can also say that 2 times angle 1 is equal to GFJ, and 2 times angle 3 equal to angle GHJ. And then what do you do? Since angles GFJ and GHJ are congruent, 2 times angle 1 is equal to 2 times angle 3. So angle 1 is equal to angle 3. Therefore, the 4 angles are congruent. There you go. Okay. Let's look at the next page now. Example 3. Use diagonals to identify rectangles. Ashton measures the diagonals for his deck frame and finds that they're congruent. Will the deck be rectangular? Since opposite sides are congruent, because that's 8 feet and these are 10 feet, and they measure the diagonals and they're congruent. The supports form a parallelogram. To show the structure is rectangular, you need to show the angles are right angles. And since the opposite sides and the diagonals are congruent, you have triangles that are congruent. ACD and BDC are congruent. So we're talking about here, ACD and wait, we don't know it's the right angle yet, but BDC. Okay, we're talking about these two triangles by SSS. These two are congruent. DC is equal to itself CD, and then the diagonals are congruent. They said so. They're by SSS, they're congruent, right? In parallelogram, consecutive angles are supplementary. So this is another information that's important for you to remember about parallelograms, okay? Angles that are congruent and supplementary are right angles, right? Because supplementary means they need to add up AB to be 180 degrees, but if A is equal to B, then A and B are right angles. And similarly, DAB, so now talking about the top triangles here, must also be right triangles with the same logical reasoning. The triangles are congruent by SSS, and since the parallelogram has congruent and supplementary angles, they're going to be, the consecutive angles that are supplementary, you know they're going to be congruent and supplementary, which is right angles. So the frame forms a parallelogram with four right angles and congruent angles, which is a rectangle. So try number 3, if the diagonals of any quadrilateral are congruent, is the quadrilateral a rectangle? Justify your answer. So does that work for any quadrilateral and for all the diagonals that are congruent? What about a trapezoid? You could have congruent diagonals. Is it a rectangle? No, not really. So what makes it a rectangle? Not just congruent diagonals, but also they need to bisect each other. These need to be bisected, the sides of the lengths of the diagonals. Okay, so trapezoid is a really good example of where you can find congruent diagonals, but they're not always a rectangle. And it's still a parallelogram, but it's just not, wait, it's not a parallelogram, but it's still a quadrilateral. So if it's a parallelogram that has congruent diagonals, then you know it's a rectangle. But for quadrilaterals, it could be a trapezoid. So it's not always. No. If the diagonals do not bisect each other, quadrilateral is not a parallelogram. So it cannot be a rectangle. Okay, because that's also a property of parallelogram. So in order to be a rectangle, first it needs to have all the properties of parallelogram, and then you have some special characteristics for the rectangle. So you can't just use the properties of rectangle even when it doesn't satisfy the parallelogram first. It needs to satisfy the characteristics of the parallelogram, and then it's a rectangle. Must, so special parallelograms. Parallelograms must first satisfy the characteristics of parallelogram before the special the special parallelograms, obviously. Okay, so I hope I worded this correctly or in an easy way. Okay, so first, special parallelograms must be a parallelogram first, and then you can see what type of special parallelograms they are. If it's not even a parallelogram, then it's not going to be special parallelogram. Okay, so remember that, it's very important. Sometimes it gets tricky. So theorem 6-21 is the converse of theorem 6-18. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. And notice diagonals of a parallelogram. Okay, diagonals of quadrilateral is not, they're not equal to each other. Okay. So any quadrilateral doesn't work. It must be a parallelogram. Okay. So example 4, identify special parallelograms. Can you conclude whether each parallelogram is a rhombus, a square, or a rectangle? Explain. So in example 4, you're going to see different parallelograms and you want to classify using the theorems. Identify special parallelograms. So A, B, C, D, you know the diagonal bisects the angle. First, you want to prove that the triangles are congruent by SAS. So this side and that side are congruent. BD is congruent to itself. So you know by SAS, the triangles are congruent, ABD and CBD. And by CPCTC, you know that these two angles are congruent, right? And so that means BD bisects angle B. And since diagonal BD bisects the angles, right, these also must be congruent by CPCTC. The parallelogram must be a rhombus. Okay, so it's a rhombus. All sides are congruent. Right. Okay. What about part B? Parallelogram PQRS. Diagonals are perpendicular is given, right? So it's a rhombus. And the diagonals are congruent, so it's also a rectangle. So it's both rhombus and rectangle. What's it called? It's a square. If it's both rhombus and rectangle, it's a square. If it's just rhombus, then it's a rhombus. If it's just rectangle, then it's a rectangle. If it's both, it's a square. Okay? If it's none, it's not a special parallelogram. Okay? All right, try number 4. Is each parallelogram a rhombus, a square, or a rectangle? See if you can identify these parallelograms as special parallelograms in parts A and B. Come back when you're ready for answers. Okay, the first one. You know that HL is congruent to GL. So first let's start with a property of the parallelogram. It's a parallelogram. So in a parallelogram, the diagonals bisect each other. So HL must also be equal to LK and GL must also be equal to LJ. So then the diagonals are congruent, right? Since HL and GL are congruent, all these parts of diagonals are congruent, which means it's a rectangle, right? So part A, it's a rectangle. Parallelograms. In a parallelogram, the diagonals bisect each other. Since HL is congruent to GL, they must also be congruent to all HL, LK, KL, GL, and JL. And that means then the diagonals are congruent. So it is a rectangle. Okay, that's part A. What about part B? You know that the diagonal UW bisects this angle U right here, right? How do you know if it also bisects angle W? How do you know? Since in a parallelogram, opposite angles are congruent, angle U must be congruent to angle W in a parallelogram. Because in a parallelogram, opposite angles are congruent. And then you can say that since Since the diagonal bisects opposite angles, it's a rhombus. So write that down. Angle U is congruent to angle W because in a parallelogram, opposite angles are congruent. And since a diagonal bisects opposite angles of the parallelogram, PUVW is a rhombus. Okay. Let's look at example 5. Use properties of special parallelograms. Quadrilateral STUV is a rhombus. What are the values of X and Y? Now we're going to use properties of rhombus to figure out the variables. What do you know about the rhombus? The diagonal must bisect the opposite angles. So the diagonal TV must bisect the opposite angles, which means 65 minus y must equal to 5y plus 5. And these two also must be equal to each other. You can set up two equations and solve for each variable. X is 13, y is 10. Okay, so use the property of special parallelograms. Try number 5. In a parallelogram ABCD, AC is equal to 3W minus 1, and BD is equal to 2 times W plus 6. Okay. You don't know what ABCD is, but this is not drawn to scale, okay? AC is the diagonal because A and C, they're not consecutive. You know it's going to be opposite vertices. So the length here is 3W minus 1. BD is 2 times W plus 6. In order to be a rectangle, what is the property of diagonals of a rectangle? They must be congruent. So 3W minus 1 must be equal to W plus 6. So solve for W and see what value of W makes it true. You can't just stop here. What must be true? What does W have to be, in other words? Okay, so solve for it. 2 times the parentheses, distributive property. You can say 2W plus 2 times 6 is 12. And then subtract 2W on both sides. You get 1W. Add 1 on both sides, and you get 13. So W must be 13. Okay. All right. Application, the last example. Apply properties of special parallelograms in real world problems. First of all, you need to keep in mind that the order in which the quadrilateral is identified matters. Okay, so be sure to first show that it's a parallelogram before applying the theorems to identify quadrilateral as a rhombus or a rectangle. Because if they just say it's a quadrilateral, then you don't know if it's a parallelogram. First, you need to show it's a parallelogram and then apply the special parallelograms. Okay. A group of friends set up a cakewalk field with bases 60 feet apart. So all sides are congruent. How can they verify that the field is a square? So first, see if it's a parallelogram. Opposite sides are congruent, so it must be parallelogram. Okay, and then all sides are congruent, so it's a rhombus. Now what do we need to know? It also needs to make a rectangle to verify it's a square. So the field is a rhombus. You can show that the rhombus is a square by proving it's a rectangle as well, right? Parallelogram is rectangle if the diagonals are congruent. So you can measure the distances from the opposite plates. So home plate to the plate over here, the second base, and first base to the third base, they're gonna form diagonals, right? And you know if it's a square, if the diagonals or the distances between these bases and the opposite bases, right, are congruent, then it's also a rectangle and it must be a square. Okay, so the question was, how can they verify? You just need to explain how. You don't have to prove it. But basically, algebraically, you can use well, you can't use the Pythagorean theorem yet because you don't know if it's a right angle. Yeah, so basically that's the best you can explain. So let's look at trend number 6. Is M and PQ a rhombus? Basically, are all the sides equal to each other? Okay. What are the special properties of a rhombus? First, verify that it's a parallelogram. How do you know it's a parallelogram? Because the diagonals bisect each other, right? And so it's a parallelogram. And how do you know it's a rhombus? Well, look at the angles over here. 58 and 58, they're congruent, right? And then what? You can also try to see if this diagonal bisects the other angles. Okay, why do you need 32 though? Because 58 plus 32 is what? 90 degrees. So since 32 plus 58 is 90 degrees, what is the last angle? It's right angle. Then if that's right angle, that's also right angle because it's a linear pair. That's also right angle, and that's also right angle. These are all right angle. So the diagonals are perpendicular and they bisect each other. So diagonals being perpendicular bisector, you know it's a rhombus. It needs to be a rhombus. So let's summarize and add that. It is a rhombus. The diagonals bisect each other. So it's a parallelogram. Always start with a parallelogram, okay? And then the angle MRQ is 90 degrees. Or you can say is 180 minus 32 minus 58, which is 90 degrees. So the diagonals are perpendicular. And a parallelogram with perpendicular diagonals. Okay, so one by one, logically prove that it's a rhombus. You can say, yes, the diagonals bisect each other, so it's a parallelogram. Angle MRQ is 90 degrees by the triangle angle sum theorem. And so the diagonals are perpendicular. The parallelogram with perpendicular diagonals must be a rhombus. Okay, so let's summarize our lesson. That was basically it. So in order to be rhombus, you need to have diagonals that are perpendicular or a diagonal that bisects the opposite angles. Okay. If it's a rectangle, if a parallelogram is a rectangle, then the diagonals are congruent. So just looking at the diagonals, right? Diagonals are perpendicular, diagonal bisects angles for rhombus. If diagonals are congruent, then it's a rectangle. It's a square if it's both, right? So basically, you can also check if the diagonals are perpendicular and congruent, or if diagonal bisects angles and diagonals are congruent, they meet all these, then it's a square. Okay, so these two are different. The first condition, the diagonals are perpendicular and congruent. The second condition, you don't know if they're perpendicular, but the diagonal bisects angles and the diagonals are congruent, it's basically going to be perpendicular. But if once you have these information, then it's enough to say, oh, it's a square. I don't need to look further. Okay. All right, so that was lesson 6, the last lesson of this topic, conditions of special parallelograms. And we're done with topic 6, quadrilaterals and other polygons for today. So if you have any questions, further questions, please ask Ms. King in class. And I'll see you in the next topic. Bye. Great job, everyone.